Welcome to this captivating exploration of the latest advancements propelling the dynamic growth of wind energy. In recent years, the landscape of wind turbine technology has experienced a sweeping transformation, ushering in an era of unprecedented efficiency, sustainability, and amplified power generation. In this electrifying journey, we'll traverse the cutting-edge realm of progress, where towering turbines, ingenious control systems, state-of-the-art materials, and revolutionary design strategies converge to reshape the very foundation of renewable energy. As we embark on this voyage, we'll delve into the fascinating world of wind turbine innovation, where traditional limitations are being shattered by groundbreaking solutions. From the ascent of colossal turbines that reach towards the skies to harness the untapped potential of high-altitude winds, to the intricate dance of advanced blade designs, crafted to slice through the air with unparalleled precision, every facet of wind energy is undergoing a revolutionary evolution. But the revolution extends far beyond the physical form. Within the heart of each turbine lies a network of intelligent control systems that possess the ability to decipher the language of the wind itself. These systems, fueled by real-time data and predictive algorithms, orchestrate a symphony of movement, optimizing the pitch of the blades, the alignment of the turbine, and myriad other variables to extract every possible joule of energy while ensuring the turbine's longevity. Intriguingly, the foundation of this transformation also rests on the materials that constitute these towering structures. Pioneering materials like lightweight carbon fiber composites and innovative manufacturing techniques, such as the marvel of 3D printing, converge to craft blades and components that are stronger, lighter, and more cost-effective than ever before. This harmonious fusion of advanced materials and cutting-edge production methods not only bolsters efficiency but extends the operational life of these wind giants. But that's not all. Our exploration delves into the open waters, where the concept of wind energy takes an audacious leap. Floating wind turbines, unfettered by shallow seabeds, now have the power to harness the potent energy of deeper ocean winds, expanding the scope of offshore wind farms to previously uncharted territories. In this journey, we'll uncover the transformative potential of predictive maintenance systems, supported by a network of IoT sensors, ushering in an era where potential turbine issues are preemptively identified and addressed, minimizing downtime and costs. And let's not forget the power of collaboration. Wind energy is now joining forces with other renewable sources like solar and energy storage, crafting hybrid systems that offer a more stable and reliable power supply, ultimately fortifying the backbone of our energy infrastructure. As we traverse this landscape of innovation, we'll also witness the revival of aging wind infrastructure, where the end of one turbine's lifespan marks the dawn of a new chapter, a chapter of recycling, repurposing, and sustainable renewal. So, fasten your seatbelts as we embark on a journey through the winds of innovation, a journey that promises a cleaner, greener, and more sustainable future for generations to come. Welcome to the forefront of wind energy evolution, where science, engineering, and the power of nature harmoniously converge to revolutionize the way we generate power and pave the way for a brighter tomorrow. In recent years, there have been significant advancements in wind turbine technology that have driven the growth of wind energy. These advancements aim to increase efficiency, reliability, and overall performance of wind turbines, making them more competitive and appealing as a renewable energy source. Some of the notable advancements include increased turbine size. One of the most prominent trends is the development of larger wind turbines. Bigger turbines with higher hub heights and longer blades are able to capture more wind energy at higher altitudes where the wind is stronger and more consistent. This results in increased energy production and improved efficiency. Advanced blade design. Wind turbine blades have undergone extensive research and development to improve aerodynamics and efficiency. New blade designs are optimized to reduce aerodynamic drag, noise, and turbulence, allowing for greater energy capture at lower wind speeds. Smart control systems. Modern wind turbines are equipped with advanced control systems that use real-time data and predictive algorithms to optimize performance. These systems adjust the pitch of the blades, the yaw of the turbine, and other parameters to maximize energy production while ensuring the structural integrity of the turbine. Floating wind turbines. Traditional offshore wind farms are fixed to the seabed, limiting their deployment to shallow waters. However, floating wind turbines are being developed that can operate in deeper waters, expanding the potential locations for offshore wind energy generation. Direct drive generators. Conventional wind turbines use a gearbox to increase the rotational speed of the blades to a level suitable for electricity generation. Direct drive generators eliminate the need for a gearbox, reducing maintenance requirements and increasing efficiency. Materials and manufacturing advances. Innovations in materials such as carbon fiber composites and advanced manufacturing techniques like 3D printing are making wind turbine components lighter, stronger, and more cost-effective to produce. This leads to reduced maintenance needs and longer lifespans for turbines. Turbine placement and layout optimization. Improved wind resource assessment tools and advanced modeling techniques enable better selection of turbine locations and optimized layout designs within wind farms. This ensures efficient energy capture and minimizes wake effects between turbines. Condition monitoring and predictive maintenance. Internet of Things, IoT, sensors and data analytics are being integrated into wind turbines to monitor their performance in real time. This allows for early detection of potential issues and enables predictive maintenance strategies, reducing downtime and maintenance costs. Hybrid systems. Wind energy is being integrated with other renewable sources like solar or energy storage systems to provide a more consistent and reliable power output. Hybrid systems help balance fluctuations in energy production and improve overall grid stability. Repurposing old infrastructure. As older wind turbines reach the end of their lifespan, efforts are being made to repurpose or recycle their components. This reduces waste and environmental impact while making way for newer and more efficient turbine technologies. These advancements collectively contribute to the increased competitiveness of wind energy by driving down costs, improving reliability, and expanding the potential for wind power generation in various geographical locations and environmental conditions.